Okay, so thanks everyone. We are all a bit tired, but I hope I won't be bothering too much. And thanks to Pablo and Zaskun and Plexus. I'm not part of Plexus, but I got fundings to come.
You should
so
be. You should be.
no, but so of course I am. Oh, I have some.
Pablo, we have to talk with the people in Torino.
Okay, so as the title of the talk suggests, I'm going to talk about variable inclusion logics, in parentheses through substructurality, because, well, so my PhD project is related to these logics in general, and with Agustina, who I included here, you all know her, we started working on a very nice exploration for this project, which actually is opening so many new questions, and so maybe some of you are familiar, I mean, I'm sure some of you already are familiar with these logics, some others maybe not, but I would be very happy to hear some feedback on like possible ways to develop this. So I will say something about variable inclusion logics, what they are, what's the motivation for studying and developing these logics. I will talk about some refinements that have been proposed for these variable inclusion requirements that characterize these logics. Some of them are, some of them are by me and Agustina, some of them by Damian and others. And I will also talk about some philosophical interpretation that we can give, for, at least for some of these refinements. So, yeah, that's the plan. Okay, let's start with weakly logics. Actually, with variable inclusion logics in general. So, what is the idea behind variable inclusion logics? Well, we can think of as initial motivation for the development of these logics the concerns regarding relevance in inferences. So, for instance, we all know that in classical logic we can say 2 points determine a straight line, hence either it is raining in Pamplona or it isn't, or it is sun in Pamplona and it isn't, therefore the moon is made of cheese. Oh no, I didn't, I thought I changed it here. Okay. Another example, so 2 points determine a straight line, thus 2 points determine a straight line, or Agustina hates mate. I wanted to change the clearly false statement with another clearly false statement. Actually, I'm not sure whether this contradiction is false, because in Pamplona it's rainy, not rainy, so anyway, the idea is...
yeah, you could put the moon is made of cheese, hence Agustina hates mate. I think that could be...
Yes, also, yes. So yeah, we all know that in classical logic we have these inferences that are valid, but we don't really like them because it feels like there is not a connection between the premises and the conclusion of our arguments. So yeah, this is the idea. We basically, this idea of relevance, we can capture it as demanding for some content sharing or even more inclusion between premises and conclusions. And the assumption, the standard assumption in these logics is that the content of a formula is nothing but the set of variables, of propositional variables occurring in that formula. So these all are propositional. Actually, there's some refinements that put this into question, but I'm not going to talk about it too much. So, and of course, for a set of formulas, the set of variables of the formulas in the set of formulas will be the content of that set. So we say that for an inference, gamma entails delta, we have right variable inclusion when the variables of delta or the conclusions are included in gamma. Vice versa, we have left variable inclusion. As you may notice, we are working with multiple premise and multiple conclusion settings, and here the understanding of the disjunction, since we talked about it with Damian, is of the comma on the right is conjunctive, on the left is disjunctive. Yeah, conjunctive, disjunctive.
Yeah, left.
Yes. I'm sorry.
No, it's fine.
You have been working a lot.
Yeah, I might say stupid stuff. So, I think we mentioned weakly logics. Yes. These are the truth tables, but maybe we didn't see them. So for those of you who don't know them, weak-linear logics are a kind of variable inclusion logics. We have, again, as I said, a sentential language, so we are all propositional. We have 3 truth values, 1, 1/2, and 0. So true, false, and this 1/2 can be interpreted in many ways. There's many interpretations for that. And the characteristic feature of these logics is that they are infectious contaminant logics because there is an infectious contaminant value, this 1/2. That means that basically whenever a formula has value 1/2, however you combine it with any other formula, with any operator, with no matter what is the value of the other formulas, the result will be 1/2. So this non-classical value infects the complex formulas. Okay, we have 2 weak-linear logics, para-consistent weak-linear and para-complete weak-linear, or simply weak-linear logic. As you may, as the name hints, we have that para-consistent weak-linear preserves non-falsity. So if we have non-false premises, we have at least one non-false conclusion. So our designated values are 1 and 1/2. In the para-complete case, we are preserving just truth. So we have that para-consistent weak-linear is para-consistent in the sense that explosion in this form fails. And para-complete weak-linear is para-complete in the sense that ex falso fails. Sorry, the low excluded middle fails. We have that also, something that is characteristic of these logics is that simplification or conjunction elimination fails in para-consistent weak-linear, while addition or disjunction introduction fails in the para-complete case. Why so? Because in para-consistent weak-linear, I'm sorry.
No.
I mean, you know this already. Para-consistent weak-linear, if we are preserving non-falsity. So if we consider the case in which phi is 0, and psi 1/2, this is 1/2, and this is 0. So we have a false conclusion. Addition is invalid in here because we are preserving only 1. So this might be 1, but if psi has value 1/2, the disjunction is 1/2, so the conclusion is not true. So as I said, variable inclusion logics are logics that are characterized in some way with this variable inclusion requirement. In general, the left variable inclusion companion of a logic L is defined as follows. So we have 2 clauses. The first clause tells us that the left companion satisfies an inference if and only if either 1, there is some theorem in the conclusion, theorem in L. 2, there is a non-empty subset of gamma such that gamma prime such that gamma prime entails delta in L, and the variables of gamma prime are included in the variables of delta. And the dual for the right companion. So here we are not counting theorems but anti-theorems, and the inclusion requirement is from right to left. So when L is classical logic, I already said it, the left and right variable inclusion companions of classical logic are respectively para-consistent weak-linear and para-complete weak-linear. So para-consistent weak-linear has classical theorems and then the inclusion. Para-complete weak-linear has the anti-theorems and then inclusion. So there have been some critiques to this, let's say, variable inclusion requirements, characterizations. Namely, clause 1, as you saw, allows for exemptions to the variable inclusion, because if we have for instance, if we have the classical theorem in here, well, gamma can be anything. By monotonicity, we can add anything in the premises, so there is no inclusion anymore from left to right. And if we have anti-theorems, in the right case, delta can be anything, so we can derive anything from a contradiction, basically. So also in that case, variable inclusion is not satisfied. Clause 2 is a requirement of variable inclusion, but as you may have noticed, let's go back. We are only requiring for a subset of the premises or conclusions to be included on the other side. So again, there we can add irrelevant stuff, and okay, there's some sharing of variables of content, but we can always add other stuff that we don't want. Then something that I'm just mentioning, but I won't talk about it, is, as I said, this idea of content. There have been some other proposals. For instance, negation is not considered to be topic transparent or content transparent. So like P and not P would have a different content. And in that case, you would have to define a variable inclusion in a more fine-grained way, like counting the positive occurrences of variables, the negative occurrences, and then ask for that kind of inclusion. It's very interesting. Damian and Maru, a girl from Buenos Aires, worked on that. But yeah, I'm not going to talk about it. So for the moment, we are considering the content to be just a set of variables. Okay, some refinements for these logics that have been proposed. Dropping clause 1. So we are doing exactly the same as before, but we call these new companions pure left and pure right. That's what Paoli and others did. And basically, we just keep the second clause. So we want gamma, we want a so we basically want that gamma entails delta in the pure companion, if and only if in L we have that gamma entails delta and there is a non-empty subset of gamma, we call it gamma prime, such that its variables are included in delta. So we are not keeping the theorems anymore. But still we have this subset thing, that gamma prime cannot be empty, okay? That's the dual in the right, pure right companion. So yeah, the key difference is that while in the left-right companions we had theorems and the theorems, here we don't have them. Another refinement, so we drop clause 2, that's what we did with Agustina. I mean, not drop, we restrict it. So basically, we keep clause 1, so we keep theorems. In the left variable inclusion case, we keep anti-theorems. But then we ask for the whole set of the variables in the premises to be included in the set of the conclusions, and vice versa. So how do we do that? We define these two logical consequences. We call them we did it for weak-linear logics. We found some generalization of this, but not for any infectious Tarskian logic. But the idea is, okay, let's consider weak-linear logics. The idea is, okay, we take uniform paraconsistent weak-linear, and it is just the same as taking the formula fragment of paraconsistent weak-linear, because we are taking the big conjunction of the premises, the big disjunction of the conclusions, and we do the same here. In fact, if we look at the previous characterization of the left-right companions, if we only consider formula inferences, that's basically what you are going to get. I will say why this is nice. But, maybe I say it now. It's better. So the idea is, in paraconsistent weak-linear, you don't have disjunction, conjunction elimination, but you have this by reflexivity and monotonicity and weakening in paraconsistent weak-linear. While in paracomplete weak-linear, you have that this fails, but this is valid. So, we can motivate this from different points of view. Here I'm presenting a motivation of this work from the variable inclusion point of view, so as a refinement of these logics, but actually without me to work on that as like finding a correspondence between language and meta-language, because in these logics conjunction on the left is doesn't match the behavior of the comma, vice versa, and here we have the same problem on the right. I mean, we have some reasons why this could be a problem, so how to solve it? Well, let's make them behave in the same way. We make the comma behave infectiously, basically. And so in the uniform companions, we also have that these inferences fail. This is the idea. Another alternative, well, we drop both clauses, or restrict clause 2 and drop clause 1, so we don't have theorems or anti-theorems, and we demand for the whole inclusion of variables. So this corresponds to taking the intersection of the pure companions and the uniform companions of a logic. In the case of classical logic, we have that gamma entails delta in this intersection if and only if gamma is non-empty and the variables of gamma are included in the variables of delta. The right case, we have that delta is non-empty and the variables of delta are included in gamma. So the non-empty thing is saying, okay, we don't want theorems, we don't want anti-theorems, and then we are demanding for the whole inclusion. Interestingly enough, we have a semantics for this, but not a sequence calculus at the moment. I mean, not a proof system. No, yes. But, okay, what we said with Agostina, but is this too restrictive? Because maybe the problem is not with the theorems or anti-theorems per se, but it is with monotonicity. So that's I mean, we were also substructural in the uniform companions, you know, because you have that, I didn't say it, you have that P entails P in both logics, but you cannot add stuff on the left here, you cannot add stuff on the right here. So yeah, what we said is, okay, maybe the problem is not theorems or anti-theorems, but the fact that then a theorem is entailed by anything and an anti-theorem entails anything. So can we find a middle ground between this, the pure companion and the uniform companion? That's what we tried to do. And in this case, we do have the sequence calculus, but we don't have the semantics. So maybe before going into that, okay, no, I will say it later. Okay. Yeah, that's what I said. So maybe the problem is not in the theorems, anti-theorems, but in the monotonicity of the logical consequence. We talked a lot about this. This is the generalization of a definition of a Tarskian consequence to the multiple premise, multiple conclusion case, but it's, I mean, reflexive, monotonic, and transitive, and substitution invariant. Yeah, okay, so the thing of monotonicity is that when you have a theorem, it is entailed by the empty set, so you can add anything there by monotonicity, and also monotonicity is the guilty one for anti-theorems entailing anything because they entail the empty set. So yeah, these new logics, this other refinement of variable inclusion would be basically this. So we do not demand anymore for having like a non-empty gamma in the left inclusion or a non-empty delta in the right inclusion. So we are including the case in which gamma is empty, so delta is a theorem. Yes, is a theorem, and where delta is empty and gamma is an anti-theorem. But when we add stuff either on the left or on the right here, it has to satisfy the variable inclusion constraint. So I don't remember where yes, this is the logics that we have basically, and here I have the so just to have a better picture of what's going on here, in classical logic we have all of this. We have that P or not P, so X to the middle is entailed by anything, for instance Q. P and not P entails Q, P and Q entails P, so we have conjunction elimination, disjunction introduction, and this sort of versions of conjunction elimination and disjunction introduction. I mean, these versions of monotonicity in a way. Para-consistent with cleaning, we said we don't have, it's a para-consistent logic, so we don't have X falso. We don't have conjunction elimination because of the infectious value, and dually in the para-complete one, we don't have theorems, and we don't have disjunction introduction. Then we have two choices. We restrict the second clause and we get the uniform para-consistent with cleaning. And that's basically asking for the non-monotonicity on the left. In the uniform para-complete with cleaning, we drop monotonicity on the right. Okay, so we have the comma behaving infectiously. The pure companions, as I said, they simply drop clause 1, so they don't accept any theorems. So we don't have X falso, we don't have theorems. And here the same, but they are uncomparable, of course, because here conjunction elimination fails, and here disjunction introduction fails. So the intersection between uniform and pure lies here, and that's the case when we don't have theorems or anti-theorems, when we don't have monotonicity on the left or on the right, but there is this step, middle step going down, that are the what we, Agustin and I didn't say it, we call them the synthetic companion of classical logic and the analytic companion of classical logic. So these are non-monotonic logics. They should be non-Tarskian, right? Right? But so we don't have that P or not P follows from Q, but we have that it follows from the empty set. Okay, so and the same idea here. Why we call them synthetic and analytic companions of classical logic? So these you might have studied Kant. I love him. So we have this distinction in Kant between analytic predicates and analytic judgments and synthetic judgments. In analytic judgment, what you do is to analyze your predicates, so you're not adding new stuff, but you're just decomposing what you already have there. While in a synthetic judgment, you are extending your predicates, so you're adding something there. This is not, so the idea that Agustin and I were trying to implement in these logics is not new. I mean, this transposition of the analytic synthetic distinction to the inferences was already discussed, for instance, in the case of conditionals, but not only that, also more recently also Damian talked about it in a very nice paper that has a very nice title. El sentido de sin sentido. So yeah, as I was saying, in an analytic judgment, we demand for the predicate B to belong to the subject A as something that is covertly contained in this concept A, while, so yes, they can also be called as judgments of clarification. Yeah. While in the synthetic judgments, we have that the predicate B lies entirely outside the concept A, though it indeed stands in connection with it. And that's important because we have judgments of amplification. So we are not just forgetting about our predicate, but we are extending it. So the idea for analytic inference is very simple. If the content has to be analytically included, well, that content has to be the content of the conclusion, so we have right variable inclusion. While analytic, not synthetic. So we believe that a nice way to formalize this idea is via this logic, so the analytic companion of classical logic, while the synthetic companion of classical logic is the, let's say, the transposition of the idea of synthetic judgments to inferences. Yeah, so via left variable inclusion. So we have that the conclusions extend our premises. I'm sorry, I'm a bit Okay, but what is the thing? We are not just asking for inclusion, but we also believe that at least in the synthetic companion, we should retain classical theorems, because in a way there's nothing wrong with stating that something like P or not P, phi or not phi is a valid formula. That's because we might understand theorems to be valid solely in virtue of the meaning of its parts. So, I mean, actually, maybe this connects to the understanding of negation as cancellation, because there is no content, so it doesn't need to be. So, like, if we have the empty set on the left, this empty set is included in the empty set, so to say. But we don't have a semantics for this. And the same kind of reasons can be given for classical anti-theorems. So, again, they can be understood as being logical falsehoods, as being false in virtue of the meaning of their parts, and not necessarily leading to triviality for this reason. So, in a way, the reason why they lead to triviality is monotony, can be seen in monotonicity. Okay, the sequence calculi. Maybe I've been talking too much. We can see them? No?
If you want to leave some room.
Maybe that, yeah.
Also para ahorrarte trabajo. To skip your work too.
Okay.
Maybe.
Okay, we have so as I said, there's no sequence calculi at the moment for, Damian actually is working. Okay, we'll go to the conclusions. Is the sequence calculi? Okay, I will show you the systems.
When you're talking about the conclusion.
Okay. So, synthetic classical synthetic companion, we have the structural rules, but a restriction on left weakening. We are just asking for the variables of the formula that we had on the left to be included in the formula on the right. And then the operational rules are a bit weird. They are intended to represent the semantics of these connectives, because we have the infectious value. So the conjunction will be designated when either both conjuncts are true or one of them is infectious, non-classical. And we can see that from the premises of the rule. Maybe it's clearer. Yeah, in the analytic case, we have the restriction on the right weakening. So yeah, what we add on the right has to be in the variables of that formula have to be included in the variables of the premises. And also here we have these rules. Actually, Agustina obtained the sequence calculi with the method by Avron and what was? Yes, some others. Yeah, the idea is that you get an n-sided sequence calculus, and you can get a two-sided sequence calculus from those. And the completeness and soundness follow from the ones that you started with. Yeah, they are both non-monotonic. And yes, and then instead, if we want uniform with clean logic, so if what was the thing? If we want theorems to be entailed by anything and anti-theorems to entail anything, we add these kind of forms of weakening. So if we have that delta contains some theorem, we can add anything on the left, and the dual for anti-theorems. Okay, conclusions. So I will say that just, okay, I talked about these logics that I really like. With Agustina, we explored some ways to complete the picture of all these ways to frame this kind of requirement of inclusion of content, of relevance. We can think about it in many ways. Actually, there is also an interpretation for these logics as defining logical consequences that are topic sensitive, which, I don't know, maybe we can also connect that to the uniform case. I didn't think about it, but and also we gave some philosophical interpretations for that with my favorite philosopher, so I'm happy. Yeah, okay, we didn't provide a philosophical interpretation for the infectious value in this context, but as I said, there's many ways to interpret that value. So maybe we can find a way to integrate those with our work, our interpretation. And also, while right companions have been way more discussed in the literature, also in their interpretation, like why they are interesting, the right companions weren't so much. So in a way, we are sort of giving them some philosophical relevance too. Future work, well, many things. At the moment, there is no sequence calculus for, Damian is working on that now, for the pure companions of classical logic. But if that were the case, we would also maybe find a sequence calculus for the intersection between pure and uniform companions. We are still looking for a semantics for the intersection. No, sorry, for the synthetic and analytic companions of classical logic. What else? Yeah, and then I just mentioned that there's this refined pure variable inclusion, the one with the positive and negative occurrences. So, there's a lot to explore also there. Like maybe there's some uniform companions also for this case, because the logics that have this other variable inclusion requirement are Tarskian, they're monotonic. So, yeah, I think yes.
I can also
feedback, suggestions.
I leave it there.
So when you say that you don't have sequence systems, it's for the two on the bottom, or
Exactly, yes.
only that?
Yeah,
That
because
one
we
you
have
do have.
them for these ones.
Huh?
We have them for this one, and this is just removing the weakening rule for theorems or anti-theorems.
So only the two on the bottom.
These two, yes. Because yeah, you don't have theorems in this case. Sorry, in this case, and yeah, and if you drop only the rule for weakening in the case of theorems here or anti-theorems here, you are not removing enough to get what you want. So we don't know yet.
No, but it's also because there's no sequence calculus for the pure companions. So.
Yes.
Which one do you want?
These ones.
Oh.
Maybe it's not going to be enough to have it, but yes, we don't even have that now. Why what we lack of here is the semantics. Because we have semantics for this, and this, we intersect them, and we intersect the matrices that characterize this logic, so maybe it's not so elegant, but there is one. Yeah.
Is there any work on, if you want to be uniform about doing both the left and the right type of variable inclusion, so like a bottom element for this matrix, maybe? Just
the equal logic.
Yeah.
It's
no, not at the moment, as far as
no, not in our framework, but in this literature, some people did this, like Epstein.
Yeah, right.
So
Maybe if you look at the formula fragment of some of these, you can find this kind of, right?
yes, here we can like forcefully define that something is like equal if it's provable in both or something like that.
Yes. Yeah, we didn't explore that, but of course that's an option. Yes. But that would be, the idea of either analyzing your premises or extending them is, I don't know what would be that.
Can you characterize UPWK with the matrices, or just like PWK plus some additional condition?
It is. We are imposing the condition on the logical consequence of paraconsistency,
Yes,
that the minimum of the premises the value of the minimum of the premises has to be, yes.
Entails the maximum.
Yes, the maximum of the conclusions.
Right. Okay. So then, yeah, you have you keep the matrices, but you add some additional condition on the logical consequence.
Exactly. Yes. The same here.
Yeah. Duality.
I was also thinking, well, we were discussing yesterday at lunch, fatidious lunch for me, with Antonio about this great paper. You remember the paper about Igor Urbas, and he was saying I really like it too. I think it's the paper. If you can help me here, like connects paraconsistency with failure of monotonicity. Discusses this, right?
In the end, it's actually, he recognizes it's actually relevance. It's not bare consistency anymore.
What's the article?
His name is Igor Urbas.
Yes.
The name of the paper is Bare Consistency.
Right. Appearing in
Yes, I don't remember something in Soviet thought.
Studies in Soviet Thought,
That's so good.
a journal from the 90s, or a collection. But the paper is one of the nicest papers that discusses paraconsistency and what if you want to diminish the effect of contradictions. How do you go about that?
Okay.
And he's very methodic, right? Step by step.
He thinks just requiring ex contradictione polite to fail is not enough to have bare consistency. So he extends that, and in the end he says we should drop weakening as well, but he recognizes that's already relevance.
Okay.
Right? Relevance is motivations.
So he connects a lot paraconsistency and weakening.
Yes.
We have to read it.
It's very good.
I didn't
Yeah,
know about
like-
it. Yeah,
yeah.
thanks.